Hello and happy quarantine, everybody. Welcome back to Fireside Math Chats with Mr. Bacallier. I wanted to talk to you a little bit more about L'Hopital's rule, which we started to talk about a few days ago. And I wanted to get into some problems that were a little bit more advanced that some of you have had questions about. So, first problem I'm going to talk to you about is this thing, which would be a pretty terrible limit to try to take normally. So, as a reminder, when we're trying to use L'Hopital's rule, the first thing that we have to do is figure out whether or not we get the indeterminate form. So we're going to try evaluating this at 0. If I input 0, I would get the sine of 0 squared. Remember, this isn't sine squared of x, this is sine of x squared, divided by 0 multiplied by the tangent of 0. The sine of 0 is 0. 0 times the tangent of 0 is 0, which means that we get 0 over 0, which means that we can use L'Hopital's rule. So what we're going to have to do now is take the derivative of the numerator and the derivative of the denominator. This, again, is not sine squared of x. This is the sine of x squared. So my outermost function in this situation is sine. So if I take the derivative of this thing, it's going to become the cosine of x squared multiplied by the chain, which is going to be 2x. And then I'm going to take the derivative of the denominator, which is a product. So with that product, I'm going to have to take the first, multiplied by the derivative of the second, which is going to become the secant squared of x, plus the second, multiplied by the derivative of the first. And we are once again taking the limit of this thing as x approaches 0 and hoping that that looks less terrible. It's not going to look less terrible. If we plug in 0 into this thing, multiplying by 2x is going to mean that this becomes 0 no matter what, right? So I'm going to have the cosine of 0 squared, which is 0. Cosine of 0 is 1, but it's being multiplied by 0. So my numerator is once again 0, and my denominator is going to be 0 times 1, plus the tangent of 0, which is just going to be 0 again, which means that we have another indeterminate form. So we're going to use L'Hopital's rule again. In order to do that, we're going to need to take the product rule up on the top, and remember this is still a limit. We have the limit as x approaches 0 of the first times the derivative of the second, that's going to be the cosine of x squared multiplied by the derivative of the second, which is just 2, plus the second, which is 2x, multiplied by the derivative of the first. The derivative of this thing is going to become the negative sine of x squared multiplied by 2x. Then we have the denominator. And I have to use the product rule again here. So this is going to become the first multiplied by the derivative of the second, and the derivative of the secant squared of x is going to become 2 times the secant of x, and then because of the chain, I have to multiply by the secant of x times the tangent of x. That's the first multiplied by the derivative of the second, plus the second times the derivative of the first, which is just going to be secant squared of x. And then I have to add on the derivative of tangent, which is secant squared of x again. Oh, so we're going to simplify this a little bit because this looks horrible. I have 2 times the cosine of x squared plus, this is 4x squared. I guess we could turn this into a minus because of this little negative that's right here. So this would be minus 4x squared multiplied by the sine of x squared divided by, down here, I've got 2 secant squared, I've got another secant squared, I've got another secant squared. So this is really plus 2 more secant squared of x. So what I could think of this as is 2 secant squared of x being multiplied by, in my first bit, this would be x tangent of x, And in my second bit, this would be, I just have 2 secant squared, so I would have just a 1. So this, again, is a limit. So let's try plugging in 0 into this horrible looking thing. The cosine of 0 is 1, which gets us out of the problem that we've had in all of the previous problems. This is no longer being multiplied by 0 right here, which means that we get 1 multiplied by 2, so we have 2 up in the numerator. This is going to be 0, so we don't really care about that. I could put a minus 0, I'm not going to worry about it. And then down on the bottom, the secant of 0, just like the cosine of 0, is 1. So that value squared is still 1, so that's being multiplied by 2. So this is 2 multiplied by 0 times the tangent of 0. We don't care about that. But this 1 means that we have a 1 here. So really, this becomes 2 divided by 2 times 1, which is going to equal 1. And that is our limit to this thing using L'Hopital's rule. It was tricky, but it was doable. I wanted to go through one more problem involving a limit as x approaches infinity to see to show people how things would look in that sort of situation. So, the problem that I was looking at was the limit as x approaches infinity of e to the 3x divided by 5x plus 200. So, without the use of a graphing calculator, if I'm trying to evaluate this limit, I don't really know what this looks like, but e to the 3x, as x gets really, really big, this number is going to grow a lot. So it's approaching infinity. This number is also going to approach a lot, or grow a lot, so it's going to approach infinity. So I can invoke L'Hopital's rule. Again, on a free response question, if you are going to use L'Hopital's rule, the first thing you have to do is show that you're going to have this indeterminate form. You can't just jump right into L'Hopital's rule, or you will get docked points for insufficient proof that you're allowed to do what you're doing. So we take the derivative of the top, which is going to become e to the 3x, multiplied by the derivative of the chain, which is going to be 3, and my denominator is going to become just a plain old 5. Well, this number, as x approaches infinity, because remember this is still a limit, is going to still get super, super big. And this number is just going to be 5. Well, if I have a number that gets super, super big, divided by 5, that number is still going to be super, super big. So, as x approaches infinity, this function is going to increase continuously. And so we can say that its limit is infinity because it's going to continue to grow in the positive direction. Hopefully that clears up some of the issues that people are having with L'Hopital's rule and starts to make people a little bit more comfortable with using it as we get closer and closer to the AP test. I hope you all are staying sane and happy, and that life is okay for you. Keep on asking questions, and I'll keep on answering them as best I can. Be well, everybody, and I'll talk to you again soon. Bye.